All right, let's do this. We're tackling a big one today, faster than light travel. Is it really just the stuff of science fiction? I mean, come on, who hasn't fantasized about zipping across the galaxy like they do in Star Wars?
It's a pretty universal dream, I'd say.
You've given us a ton of research to dig into on this. Einstein, warp drives, even these things called tachyons. It's a lot to unpack.
Yeah, it's a wild ride through some seriously mind-bending physics.
So to get started, let's talk about the speed of light. Why is it such a big deal when we talk about space travel?
Well, the speed of light is kind of like the ultimate speed limit in the universe. And it affects everything we see in space. Like, take Proxima Centauri. It's the closest star to our sun.
Yeah, I've heard of it.
The light we see from Proxima Centauri today, it actually left the star over 4 years ago.
Wow, so we're seeing the past.
Exactly, and that's why the speed of light is such a hurdle. Even at that incredible speed, it still takes years for light to travel between stars.
So if we ever wanted to visit other star systems, we'd need to find a way to, beat that speed limit.
Well, that's where things get really tricky. You see, Einstein's theory of relativity kind of throws a wrench in the works.
Oh, Einstein. He's always messing with our cosmic plans, isn't he?
Pretty much. To simplify it, Einstein's special theory of relativity says that nothing with mass can go faster than light. And if something tries, reality gets, well, very weird.
Weirder than seeing the past. Okay, I'm intrigued. Give me an example. What kind of weird stuff are we talking about?
Imagine just for a second that a spaceship somehow manages to outrun its own light. Since we see things because light bounces off them.
Right.
You could end up seeing that spaceship in 2 places at once, like it's a cosmic ghost or something.
Whoa, that would totally scramble our understanding of time. It'd be like seeing the effect before the cause.
You got it. Breaking the speed of light could mess with our whole concept of cause and effect. And then there's the whole time travel mess. Ever heard of the grandfather paradox?
The one where you go back in time and stop your grandparents from meeting? Yeah, that one always makes my head spin.
Right. Breaking the speed of light could open up a whole Pandora's box of paradoxes that just shatter our current understanding of time and reality.
Okay, so maybe exceeding the speed of light isn't the best idea. But what about those warp drives we hear about in science fiction? Are scientists actually exploring that possibility?
They are, and this is where Einstein's general theory of relativity comes into play. It says that gravity isn't really a force, but a bending of space-time.
Space-time.
Yeah, like picture a bowling ball on a trampoline. It makes a dip, right? A warp drive, in theory, would do something similar to space-time. It'd create a shortcut, like folding the trampoline, so the bowling ball instantly reaches the other side.
So instead of breaking the speed limit, we're warping the highway itself. Pretty sneaky. But wouldn't that take an insane amount of energy?
It would. That's where physicist Miguel Alcubierre comes in. He suggested that we might be able to warp space-time using something called negative energy.
Negative energy, what is that? Some kind of cosmic antimatter?
It's not complicated. We haven't actually observed it, and its existence is still debated. But the idea is that it can expand space-time behind a ship while contracting it in front, creating a warp bubble that scoots the ship along.
Okay, negative energy. That sounds a bit far-fetched, even for me. But hold on, didn't you say there was some new research that throws a curveball into all this?
Oh yeah, there is. This one's a doozy. Dr. Jared Fuchs and his team have been looking into the possibility of making a warp bubble, but not with negative energy, with regular everyday matter.
Wait, so no need for this hypothetical negative energy stuff. That changes the game completely.
Hold your horses, there's a catch. They found that this kind of warp bubble, even if possible, would only be able to travel below the speed of light.
So no breaking the ultimate speed limit just yet. Bummer. But hey, bending space-time with regular matter is still pretty cool.
Right, it's definitely a giant leap forward in our thinking. But here's the kicker. To move even a small spaceship, you'd need to squeeze the mass of Jupiter into a space the size of a small asteroid.
Okay, I'm sensing a bit of an engineering challenge there. It doesn't sound very practical. But wait a minute, what about those tachyons we mentioned earlier? Could they be the real key to faster-than-light travel?
Now, tachyons are fascinating. They're like the rebels of the particle world, always zipping around faster than light. Think of them as cosmic speed demons.
So if we can't reach the speed of light ourselves, maybe we can hitch a ride on a tachyon. It'd be like catching a cosmic bullet train.
Well, it's not quite that simple. Professor Andrzej Dragan has been doing some research on tachyons, trying to figure out how they'd behave. And the results are, well, let's just say they're complicated.
Oh, I'm sensing another but's coming. What's the catch with tachyons?
It turns out that even for tachyons, crossing the speed of light barrier in either direction would require an infinite amount of energy. So even if they exist, hitting a ride might not be an option.
Okay, so no tachyon express lane to other galaxies. But hold on, if we can't use them to travel, why are scientists so interested in them?
Ah, that's where things get really interesting. Tachyons might be the missing link between two of the biggest theories in physics: relativity, which governs the large-scale universe, and quantum mechanics, which rules the subatomic world.
I've heard those two don't exactly get along, like trying to mix oil and water.
You got it. They clash in a way that's been driving physicists bonkers for ages. But here's the thing. Dragon's research suggests that tachyons would interact with normal matter in a way that's totally random, governed by chance and probability. Sound familiar?
Wait a minute, are you saying these faster-than-light particles might actually behave according to the weird rules of quantum mechanics?
Exactly. It's like the strangeness of quantum mechanics is a reflection of these faster-than-light particles messing with our reality from beyond the speed limit.
Whoa. So even if we can't ride them across the galaxy, tachyons might be the bridge between the vastness of the cosmos and the weirdness of quantum mechanics. Now that's a twist I didn't see coming.
It's a connection that's definitely worth exploring further. It seems the more we dig into these seemingly impossible ideas, the more we realize how interconnected the universe truly is.
Okay, so maybe tachyons aren't our ticket to other galaxies, but they might hold the key to unlocking one of the biggest mysteries in physics. I'm starting to see why scientists haven't given up on the idea of faster-than-light travel just yet. The potential payoff is just too huge to ignore.
It's the perfect example of how theoretical physics, even when it sounds crazy, can lead to amazing discoveries. Even if we never build a warp drive, chasing that dream opens up whole new ways of thinking about the universe.
I love that. It reminds me that science is all about pushing the limits and questioning what we think we know. But let's go back to those tachyons for a sec. You mentioned they'd interact with matter in unpredictable ways, governed by probability. Can you break that down a bit more?
Absolutely. Think of it this way. Quantum mechanics is all about uncertainty. We can't know for sure where a particle is or how it'll act. It's like the universe is playing dice at the subatomic level.
So you're saying tachyons, these things that could mess with causality and time, might actually fit right into that quantum weirdness, like they're playing by a different set of rules.
That's the idea. Maybe the weirdness of quantum mechanics is actually a reflection of these faster-than-light particles influencing our reality from beyond the speed limit. It's a mind-bending concept, but it could change how we understand physics.
Whoa, so even if we can't ride tachyons across the galaxy, they could be the bridge between the vastness of space and the bizarre world of quantum mechanics. Talk about a scientific plot twist.
It's a connection worth exploring. The more we dig into these impossible ideas, the more we see how everything in the universe is connected.
This brings us to a big question then. Are we truly stuck with the speed of light as the ultimate limit, or is there a way to break free? What's the current research telling us?
Well, I wouldn't call it a dead end just yet. Science is constantly evolving. What seems impossible today could be textbook knowledge tomorrow.
That's true. Just look how much our understanding of the universe has changed in the past 100 years. Who knows what amazing breakthroughs are waiting for us?
Exactly. And even if faster-than-light travel stays out of reach for now, the research is already leading to some incredible advancements. Take GPS, for example. It relies on Einstein's theories of relativity to work accurately.
Wow, I never knew that. So even if we're not jetting off to other planets yet, relativity is already impacting our daily lives in big ways.
You bet. And who knows what other practical applications might come from exploring these mind-bending concepts. Maybe vacations to other galaxies are a long way off, but the search for faster-than-light travel could unlock some truly groundbreaking discoveries.
I love that optimistic outlook. It's a great reminder that science is all about pushing boundaries and exploring the unknown, even when the odds seem stacked against us.
That's what makes it so exciting. Who knows what the future holds for our understanding of the universe and where we fit into it all?
Well, after this deep dive, I'm even more fascinated by space than I was before. It's like we're getting a peek behind the curtain of reality and seeing something truly mind-blowing.
That's the power of science. It sparks our curiosity and keeps us asking questions, even when the answers seem impossible to find. It's about embracing the journey, even if it leads us down some strange and challenging paths.
Speaking of strange and challenging paths, what about wormholes? Aren't those another sci-fi staple when it comes to faster-than-light travel? Do scientists actually take them seriously?
Wormholes are a fascinating idea, but they're even more speculative than warp drives. Basically, they're like shortcuts through space-time, connecting two distant points in the universe. Imagine folding a piece of paper so 2 points touch, even though they're far apart on the flat surface.
Okay, I can visualize that, but how would we even go about creating a wormhole? Wouldn't that require some crazy exotic physics, even more so than warp drives?
You're spot on. Wormholes, if they even exist, would require exotic matter with properties we've never seen, like negative energy density.
So even more hypothetical than warp drives. Is there any actual research happening on wormholes, or are they purely science fiction?
There is some theoretical work being done, but it's very early stage. One big problem is that even if wormholes could exist, they might be super unstable, likely to collapse and trap anything inside.
Unstable, like they could collapse on a spaceship. That doesn't sound like a very safe way to travel. It'd be like taking a shortcut through a minefield.
Exactly. And even if we could somehow stabilize a wormhole, we wouldn't know where it would lead. We might not have any control of the destination. Imagine accidentally opening a wormhole to the middle of a black hole. not exactly a vacation spot.
Yikes, that's a terrifying thought. So it sounds like wormholes, while super interesting in theory, are even further out of reach than warp drives. Would you agree?
I'd say so. Wormholes, while intriguing, have even more challenges and unknowns than warp drives. For now, they're best left in the realm of science fiction.
Okay, so wormholes are off the table for now, but it's amazing that scientists are even thinking about these kinds of ideas. It really shows how far we've come in understanding the universe.
It does, and it underscores the importance of exploring these seemingly impossible concepts. Even if they don't lead to practical solutions, they can spark new avenues of research and push the boundaries of what we know.
I'm totally with you on that. It's a reminder that science is about pushing the limits and challenging our assumptions about the universe.
And that's what makes it so exciting. Who knows what incredible discoveries await us as we continue to explore the mysteries of the cosmos.
Well, on that note, I think we've covered a lot of ground in this deep dive. From Einstein's theories to warp drives, tachyons, even wormholes. We've explored some of the most mind-bending concepts in physics.
It's been quite the journey through the frontiers of scientific knowledge. And it's a reminder that even the most far-out ideas can hold the potential for groundbreaking discoveries.
Absolutely. But before we wrap up this part of our deep dive, I have one last question that's been bugging me. We've talked about all these challenges and limitations of faster-than-light travel, but is there anything in the current research that gives you, like, a glimmer of hope? Anything that suggests we might one day overcome these hurdles and do what was once thought impossible?
That's a great question. And while I don't want to get anyone's hopes up too high, there are a few areas of research that are particularly intriguing, things that could lead to breakthroughs in the future.
Okay, I'm all ears. Tell me more. What's giving you that glimmer of hope?
One area that's particularly exciting is the study of quantum entanglement.
Quantum entanglement.
Yeah, it's this phenomenon where two particles get linked, no matter how far apart they are. It's like they have this invisible connection that goes beyond space itself.
Okay, that sounds pretty wild.
If we could harness that connection, it might be possible to transmit information faster than the speed of light.
Wait, so instead of physically traveling faster than light, we could send information instantly. That's still revolutionary. Imagine the possibilities for communication.
Exactly. It wouldn't be the same as physically transporting ourselves, but it would still have huge implications for understanding the cosmos and communicating across vast distances. It's something that has a lot of scientists buzzing with excitement.
Wow, that's incredible. So while we might not be beaming ourselves across the galaxy anytime soon, the possibility of faster-than-light communication is still on the table. It sounds like the race to break the cosmic speed limit is far from over.
It's definitely an area to keep an eye on. The research is still early, but the potential is huge.
So it seems like the search for faster-than-light travel has opened up a whole new can of cosmic worms, huh? Tachyons might be the key to figuring out how the universe works on both the big scale and the tiny subatomic level. But even if they don't give us a free pass across the galaxy, it sounds like the journey itself is leading to some pretty amazing discoveries.
Absolutely. And speaking of journeys, we've touched on a few ways to potentially break the speed limit. Warp drives, which would involve bending space-time itself. And then there are those tachyons, hypothetical particles, always traveling faster than light. But are there any other contenders in this cosmic race?
Well, you did mention wormholes earlier. They sound like something straight out of a science fiction movie, but is there any real scientific basis to them? Could they actually work for faster-than-light travel?
Wormholes are definitely one of the most intriguing possibilities. They'd be like tunnels through space-time, connecting two distant points in the universe. Think of it like folding a piece of paper, so 2 points touch even though they're far apart on the flat surface.
Okay, I can picture that. But wouldn't creating a wormhole require some seriously mind-bending physics? Is it even theoretically possible?
Theoretically, yes. Einstein's theory of general relativity suggests that wormholes could exist. But there are some major hurdles. The biggest is that they would require something called exotic matter, stuff with properties we've never seen, like negative energy density.
Negative energy density. That sounds like something out of a science fiction novel. Is there any evidence that something like that even exists?
Unfortunately, no, and that's one of the main reasons why wormholes remain purely theoretical. We haven't observed anything that behaves like exotic matter, and we don't even know if it's possible to create.
So wormholes are kind of like a cosmic pipe dream for now. A cool idea, but not much scientific support.
That's a fair assessment. But remember, even the most groundbreaking scientific discoveries often start as seemingly impossible ideas. Who knows, maybe someday we'll unlock the secrets of exotic matter and figure out how to create stable wormholes.
I'm holding on to that sliver of hope. But even if wormholes stay in the realm of science fiction for now, it's amazing that scientists are even considering such possibilities. It really shows how far our understanding of the universe has come.
Absolutely. It highlights the importance of not dismissing ideas just because they sound strange. Sometimes the most radical concepts lead to the most profound discoveries.
All right, so we've talked about warp drives, tachyons, and wormholes. Are there any other contenders in this race to break the cosmic speed limit? Any other wild ideas physicists are exploring?
There's one more I'd like to discuss. It's closely related to the warp drive idea we talked about earlier. It's called the Alcubierre-White warp drive.
Wait, didn't you say that warp drives require negative energy, which we haven't even observed yet?
Right. The original Alcubierre warp drive relied on negative energy to create a warp bubble around a spacecraft, essentially contracting space-time in front of the ship and expanding it behind.
So how does this Alcubierre-White version differ? Is it also reliant on this elusive negative energy?
This is where things get really interesting. Physicist Harold White proposed a modification to the Alcubierre drive that might allow it to work using positive energy, which is something we're much more familiar with.
Positive energy, and that sounds a lot more attainable than trying to wrangle negative energy, which we don't even know exists. How would that work?
White's idea involves creating a ring of exotic matter. It would generate a super powerful gravitational field strong enough to warp space-time around a spacecraft. This would essentially create a warp bubble that would push the ship forward.
So instead of contracting and expanding space-time directly, we're creating a localized gravitational wave that pulls the ship along. It's like riding a wave of gravity across the cosmos.
That's a great analogy. And the most exciting part is that this modified warp drive wouldn't need any negative energy, which we already know is a major problem for the original Alcubierre concept.
This sounds incredibly promising. Is there any experimental evidence to support White's theory? Has anyone tried to make this exotic matter ring?
Unfortunately, no. The Alcubierre-White warp drive is still very much theoretical. The math seems to work, but we're a long way from having the technology to test it. It's a really cool possibility, but we'll need to wait for more research and technological advancements before we can know for sure.
Okay, another one for the wait-and-see category. But it's exciting to know that physicists are actively exploring these seemingly impossible ideas. It fuels my hope that we might one day overcome the barriers to traveling faster than light.
And that's the beauty of science. It's all about pushing the boundaries of what we know and exploring the unknown, even if it leads us down some unexpected paths. The quest for faster-than-light travel has already led to incredible breakthroughs in understanding the universe, and who knows what other discoveries await us as we continue to push the limits of human knowledge.
Speaking of pushing the limits, we've been talking about ways to potentially travel faster than light. But is there any research exploring the possibility of sending information faster than light? Even if we can't physically travel at those speeds, wouldn't instant communication be a game changer?
Absolutely. That's where quantum entanglement comes in. It's one of the most bizarre and counterintuitive phenomena in quantum mechanics, and it might hold the key to faster-than-light communication.
Okay, I'm intrigued. Tell me more about this quantum entanglement. How could it potentially allow for faster-than-light communication?
It's a phenomenon where two particles become linked, no matter how far apart they are. It's like they have an invisible connection that transcends space itself. When you measure the state of one entangled particle, you instantly know the state of the other, even if they're billions of light years away.
Whoa, that sounds like something straight out of a science fiction movie. It's like they're communicating instantly, ignoring the speed limit of the universe.
It's one of those things that makes you question everything you thought you knew about reality. And while we don't fully understand how it works, the experimental evidence for quantum entanglement is undeniable.
So if we could somehow harness this entanglement, could we use it to send messages faster than light? Imagine being able to communicate with a distant spacecraft in real time with no lag.
That's the dream. And while there are still many challenges, the potential for faster-than-light communication through quantum entanglement is really exciting. Researchers are working on ways to encode information onto entangled particles and transmit it over vast distances.
This is mind-blowing stuff. So while we might not be physically traveling faster than light anytime soon, faster-to-light communication is still on the table. It seems like the future of interstellar communication might be more about quantum entanglement than warp drives.
It's definitely a possibility worth exploring. And who knows, maybe someday we'll even figure out how to combine the principles of warp drive tech and quantum entanglement to achieve both faster-than-light travel and instantaneous communication.
Okay, so we've got warp drives bending space, tachyons always outrunning light, and even the potential for quantum entanglement to transmit information faster than light. It's like the universe is teasing us with these possibilities. But let's be real, we've also hit some serious roadblocks. We're talking about exotic matter that's never been observed, mind-boggling amounts of energy needed, and even the potential for paradoxes that could unravel the fabric of reality. So where do we go from here?
Well, it's a classic dilemma, isn't it? We're staring at the edges of what we know, and those edges, they often blur into the unknown. It's tempting to get swept up in the excitement of these groundbreaking concepts, but it's important to acknowledge the immense challenges ahead.
But isn't that part of what makes it so exciting? It's like we're standing at the foot of Mount Everest, knowing the climb will be treacherous, but the view from the summit could change everything.
You're exactly right. It's about embracing that sense of wonder and pushing the limits of human ingenuity even when the path forward is uncertain. And remember, even if some of these specific ideas, like wormholes or certain types of warp drives, turn out to be impossible, the quest itself has already led to incredible insights.
You're right. Just thinking about the potential of tachyons to bridge the gap between relativity and quantum mechanics is mind-blowing. Who would have thought that these hypothetical particles, always breaking the speed limit, could hold the key to unifying two of the most fundamental theories in physics?
It really highlights the interconnected nature of the universe. Sometimes the most unexpected discoveries come from exploring seemingly unrelated areas of research. And who knows, maybe the pursuit of faster-than-light travel will lead us to a completely new understanding of physics that goes beyond anything we can imagine right now.
I'm definitely ready to have my mind blown wide open. But let's shift gears for a moment. We've been focusing on the scientific aspects of faster-than-light travel. But what about the bigger picture? If we ever crack this cosmic code, what kind of impact could it have on humanity as a whole?
That's the real question, isn't it? The implications go way beyond just science and technology. Faster-than-light travel would fundamentally change how we see ourselves, our place in the universe, and our relationship with other potential life forms out there.
Imagine being able to visit other star systems, to see firsthand the diversity of planets, and maybe even encounter alien life. It would be like opening a cosmic treasure chest.
A tantalizing prospect for sure, but it comes with a huge responsibility. We'd be stepping onto a galactic stage where our actions could have consequences that ripple across the cosmos.
It's like the old saying about great power and great responsibility, right? We'd have to approach interstellar travel with wisdom and humility, recognizing that we're not the only ones in this vast universe.
Absolutely. If we were to encounter other intelligent civilizations, how would we interact with them? Could we bridge the gaps between our cultures, our languages, even our ways of understanding the universe?
It's a question that science fiction has been exploring for ages. From Star Trek's Prime Directive to countless stories about first contact, we've imagined both peaceful encounters and devastating conflicts.
And it's not just about how we interact with alien life. Faster-than-light travel would raise some serious ethical questions about our own society, too. How would we manage access to this technology? Would it worsen existing inequalities or create new ones?
Those are some heavy questions, but they're ones we need to start thinking about now. While faster-than-light travel is still mostly theoretical, if we wait until it becomes a reality, it might be too late to prevent some serious consequences.
I completely agree. We need to approach this with both excitement and caution and a deep sense of responsibility. Faster-than-light travel has the potential to usher in an amazing new era for humanity, but it also has the potential for unimaginable destruction. It's up to us to make sure we use this power wisely.
Those are wise words. It's a good reminder that scientific progress always needs to be balanced with ethical considerations. We need to think not just about what we can do, but about what we should do. And when it comes to faster-than-light travel, the stakes are higher than ever.
Absolutely. The future of humanity, maybe even the future of the universe, could depend on the choices we make in the years ahead. We need to approach this incredible opportunity with excitement, but also with caution and a deep sense of responsibility.
Okay, so we've covered the science, the mind-bending possibilities, the technological hurdles, and even the ethical questions. It's been an incredible journey, and honestly, I'm feeling a mix of excitement and apprehension. The potential is thrilling, but the possible consequences are pretty daunting.
I think that's a very healthy and appropriate response. The quest for faster-than-light travel is a journey into the unknown. It's one we should approach with both a sense of wonder and a healthy dose of caution.
I like that. But before we wrap things up completely, I have one final question for you. Considering everything we've talked about, do you think humanity will ever achieve faster-than-light travel? Is it a dream that's always going to be out of reach? Or is there a chance we might one day break through the barriers of space-time and explore the universe in ways we can't even imagine right now?
Well, that's the ultimate question, isn't it? And to be honest, I don't have a definite answer. The laws of physics, as we understand them now, do present some pretty big challenges. But as we've discussed, our understanding of the universe is constantly evolving. What seems impossible today could become commonplace tomorrow. So I wouldn't rule anything out just yet.
I love your optimism. It's a good reminder that the universe is full of surprises and that the human spirit of exploration is incredibly powerful.
Exactly. And even if faster-than-light travel itself remains out of reach, the pursuit of that dream will undoubtedly lead to countless other discoveries that will enrich our understanding of the universe and our place within it.
Beautifully said. Well, on that hopeful note, I think it's time to wrap up this deep dive into the possibilities of faster-than-light travel. It's been an incredible journey, and I want to thank you for being our guide through this fascinating and complex landscape.
The pleasure was all mine. I encourage everyone listening to keep asking questions, keep exploring, and keep dreaming big. The universe is full of wonders just waiting to be discovered.
I couldn't agree more. So until next time, keep looking up at the stars and wondering what might be out there. And remember, the pursuit of knowledge is a journey without limits.